Today we're looking at direct variation. Identify direct variation as a function, okay, and graph direct variation. So let's go back. Slope-intercept form, what is it? Y equals mx plus b, okay? Equation or formula for direct variation, very much the same, okay? It's a linear equation. So y equals kx, okay? The y is our y coordinate, the x is our x coordinate, just like in our slope-intercept form. The k is the constant of variation. Okay, constant of variation. So you can see very much the same. Difference is m and k, and there's no y-intercept. Okay? If there's no y-intercept, what's our y-intercept? If there was no y-intercept up here when we had slope-intercept form, what was our y-intercept? Well, what was the value of b if we didn't have a value? Zero. So same here. So y-intercept, okay, always 0, 0. So in these graphs, direct variation graphs, they always go through 0, 0. Okay. So again, y and x are going to be variables. K is that constant of variation, and it'll be some number. Okay? Again, if there's no number for k, it would just be like a 1 then. So let's determine, looking at the chart. And if it is a direct variation, we'll write an equation for it then. So, looking at the chart, we're going to work backwards. Okay? So from 4, we're just going to subtract. 4 minus 3 is what? 1. 3 minus 1 is 2. 8 minus 6. 6 minus 2. Now, these don't really go in order, so we can kind of just reduce them, okay? So, 4 and 2 makes what? 4 divided by 2 is 2, right? Change of 2. What about 2 divided by 1? 2. Are these the same? Yes. So, k in this case, variation is k equals 2. Okay, constant of variation. Whatever x is, I times it by 2 to get y. And that's all my equation is. So y equals 2x for my equation. So with these direct variations, all you're doing is multiplying x by one number to get y. Okay? So take a look at b. So again, work backwards with my x's. So 3 minus 2 is 1. 2 minus 1 is 1. Now, since these are the same, really all I have to look at these values then. Okay? In A, the x values weren't the same. I had a 2 and I had a 1. So I had to kind of do some division here to get that value. Okay? So if I look backwards here, 11 to 8, 11 minus 8 is what? 3. 8 minus 4 is 4. These are increasing by the same amount. Are these increasing by the same amount? No. No. So not, okay, not direct variation. Okay? There's not a constant value here. So again, if the x's increase by the same amount, the y should also increase by the same amount. Okay? If they don't, then we have to do some division to find it out, okay? And remember, K is like that slope, right? Slope was rise over run, okay? So our K is going to be what over what? The Y over the X or the X over the Y? Rise over run. Yeah, Y over the X. So when you plug that in, take your Y change divided by X. So that's why we did the 4 divided by 2. Okay? Alright, so there's our charts. What if we have equations? So determine if the following functions represent direct variation. If so, determine the constant of the variation. So again, we need to get it in that right form. So we need to get y by itself. So in letter A, I have a 3y. How do I get rid of the 3? Divide. So divide by 3, divide by 3, so y equals 7 over 3x. Does this look like our direct variation formula? Yep. No b value, okay? So as long as b is 0, y is by itself, we're good. Okay? So what's our k value in letter A? So k is 7/3. 7/3. Good. Take a look at B. Again, solving for y, getting y by itself. So again, I need to get rid of the 7 now. How do I get rid of the 7? Divide. So we're dividing everything here by 7. So y equals 14 divided by 7 is 2x. 7 divided by 7 is 1. Now, direct variation in B? No. Why? Yeah, this guy right here. Okay? Cannot have it. So, no. Not a direct variation. Letter C. So getting y by itself. So let's move our x first. So we're going to subtract 5x. So those cancel. So 3y equals 0 minus 5x is just negative 5x. And then divide by 3 again. So y equals negative 5/3 x. Direct variation? Yep. Yeah. What's our constant? What's our k? Negative 5/3. Negative 5/3. Good. What about D? So dy is already by itself. Okay? D is already by itself. So what do you think? Is this a direct variation? Is there a way I can rewrite D to make it look a little different? How else can I write x over 9? Careful. Remember, what's with this x? What's in front of the x? A 1. So I could write 1/9 times x. Okay? So I could just pull that 1/9 out front times x. Now, does this look like direct variation? Y equals 1/9 x? Yes, it does. So what's my k? 1/9. Good. Alright, jump page 2 on the back. So here it says, suppose y varies directly with x. Y equals 9 when x equals negative 15. What's the value of y when x equals 20? So, we're first going to do this the long way. So we're going to set up an equation. So y equals kx, right? That's our equation. Y equals kx. We know y and we know x. So one option is y is 9. We don't know the k. X is negative 15. So we can solve for our k and rewrite this equation. Okay? So solve for k, we're going to divide by negative 15. So negative 9 over 15 is my k. Now does 9 over 15 reduce? Can I reduce 9 over 15? Simplify it. Yes. So I can reduce by 3. So really it's going to be 3/5. So negative 3/5. Okay? To simplify that down. So my equation is y equals negative 3/5 x. Okay? And then they say, well, what happens when x equals 20? Well, if x equals 20, I'm just going to plug it in for my x, right? So y equals negative 3/5 times 20. So again, remember, this is like that 20 over 1, so the 5 cancels with the 20. Negative 3 times 4 is negative 12. So y equals negative 12. Okay? So that's the long way. Find the actual k, plug it into my equation, plug x then into the equation, or y into the equation to find the other variable. Okay? Simplified version. Okay? Simplified version. So remember, we know k was y over x, right? Remember we talked about that? K is y over x. So I can find 9 over negative 15 equals y, y over x, which is 20. I can set a proportion. How do we solve proportions? How do we solve proportions? Cross multiply. Okay. Again, if you want to reduce before you do that, you can. Okay. So again, I could reduce 9 and 15 to 3 by 5, right? And then I can multiply. So cross multiply. 5y. 3 times 20 is 60. Divide then by 5. So y 60 divided by 5 is still, and it should be negative 12. Okay? So negative 12. So those are your two options. Okay? You're going to get the same value for both. I can find k, plug it into my equation, plug the values then into the equation. Okay? Or I can set up a proportion. Okay? I personally think proportion is a little bit less work. Okay? Just setting it up, cross multiply. Make sure y is over the x when you do this. Okay? So let's do number 6. Suppose y varies directly with x. Y is 15 when x is 3. What's the value when x is 12? So again, y over x. So 15 over 3 equals y x is 12. So again, if you want to reduce before you multiply, I would recommend that. So 15 is 3 times 5. 12 is 3 times 4. So these 3's cancel. Top to bottom. Actually, if I do it top to bottom there, okay? And then I multiply. So we'll get rid of those, go back to 12. So 5 times 12, 60. 1 times y, 1y, so y then equals 60. You could keep the 3, okay? If you cancel the other 3, that's fine. You would just then divide by 3 to get your value in, okay? Questions? Questions so far? One thing you might want to look at, if I look at this original value, 3 to 15, okay? X was 3, y is 15. Did that number get bigger or smaller? 3 to 15. Got bigger, right? So if I have 12, this value needs to be bigger or smaller than 12? My answer. Bigger. It needs to stay the same, okay? So that's one way you can quick check, did I have this kind of set up the right way? Because if I didn't, I might get a number smaller than 12. And then right away I can say, oh, I think something's wrong. Okay? So look at that relationship at the beginning. Went from 3 on an x to y is 15, got bigger, right? Same thing here, got bigger. And again, you might even look at this and say, well, 3 to 15 is what? 3 times 5. I can do the same process over here. Well, 12 times 5 is 60, and there's my answer, okay? So you might see that. Doesn't mean you have to do this all the time. You might see, oh, well, 3 to 15, that's just times 5. So I'm just going to multiply this by 5, my x, and get my y, okay? Everyone see that? Okay. So you don't, again, it's not set in stone. You don't have to follow this all the time. You might see it a little bit different on each problem. All right, number 7. The number of calories in a block of cheese varies directly with the mass of the cheese. 50 grams of cheese has 200 calories. So how many calories does 70 grams of cheese have? Okay. So x, y. Okay. So y over x, so 200 over 50 equals 70. I'm sorry. That's it. Y over 70. Okay. So again, make sure that grams are on the bottom. Okay. Calories on top. So calories, calories, grams, grams. Okay? So it does benefit you maybe to label which ones are X's and Y's, so you remember to put them in the right spots. Okay? So again, we can simplify before we multiply here if we want. So again, anything ends in zeros, we can cross out the zeros. That's our 10, right? What's 20 divided by 5? 5 goes into 20, right? 5 becomes a 1. 20 becomes a 4. So really I'm taking 4 times 70. What's 4 times 70? 280. Y times 1. So y equals 280. And is that grams or calories? Calories. Okay. One of your answers in a multiple choice question may say 280 grams. Right? Not the right label. It's got to be calories. All right, last thing. What about graphing? What about graphing? Now, a couple things with this. We can obviously make this chart. But what we say about, since there's no value here, what do we know? Starts at the origin. 0, 0, right? So I could just start at the origin. So starting at the origin, right here in the middle, 0, 0, constant 3 over 4, right? Up 3 over 4. So again, if I plug this value in, 1, 2, 3, 4, I plug 4 in for x, so 3/4 times 4, these 4's end up canceling, and I end up getting a 3 out. So y is 3. Okay. Now, that might be nice because especially with something like a fraction, okay, if I plug numbers in that don't divide evenly, I'm going to get decimal and fraction answers. Okay? So the numbers that go nicely would be multiples of 4. So I could put in an 8. So 3 over 4 times 8. Well, again, 4 goes into 8 2 times now. 3 times 2 is 6. What would the last one be if I picked, let's say 12? Again, this is increasing by 4, so this is going to increase by 3. So 6 would be, 9 would be my answer there. Okay? Constant change. But again, you can see when I have a fraction like this, these numbers can get big kind of quick, and they may not fit on your graph even. Okay, so always know, you can always start at the origin, and this constant change is like that slope, right? Rise and run, and just sketch your line. So there's my line for part A. Okay? Questions there? All right, last one. All right, y equals negative 2x. Again, where do I start at? Origin. Negative 2. So remember, this is negative 2 over 1, right? So down 2 over 1, down 2 over 1. And here's my line. We can sketch our line. Now again, if you want to do the chart, you can always plug numbers in. In this case, 0, since it's a whole number, 1 and 2, where you can do 1, 2, and 3. But easy numbers you can plug in. Plug 0 in, negative 2 times 0, 0, negative 2 times 1, negative 2, and negative 2 times 2, negative 4. And you can see those points are going to be on here. So 0, 0, 1, negative 2, 2, negative 4. Okay?